Waves are formed when a disturbance propagates through a medium. Waves can be highly diverse because of the characteristics of the medium and the source of the disturbance. The simplest types of waves are mechanical waves that travel through gases, such as sound waves that travel through the air. The source of the sound causes air molecules to vibrate. Then, molecules that are already vibrating cause neighboring molecules to vibrate as well. This process is repeated, and this is how vibration propagates. If the direction in which the particles move is parallel to that of the wave propagation, longitudinal waves occur. Sound is always longitudinal in the air. The air is first compressed and then rarefied, and thus wavefronts are formed. The distance between neighboring wavefronts is called the wavelength. If the wave speed of sound increases, its wavelength increases as well. Wave speed is the speed at which wavefronts travel. This is not the same as the speed at which the particles themselves travel. Wave speed rather characterizes the medium. However, it also depends on several other parameters, such as temperature and the frequency of the wave. The wave speed of sound in the air at a low altitude is about 1,200 kilometers per hour. At a high altitude, it is only about 1,000 kilometers per hour, as the air is colder and less dense there. However, in a dense, solid medium, the speed of sound can be much higher. The number of wavefronts that reach the observer in 1 second is called the frequency. The higher the frequency of a sound, the higher the sound we perceive. Other sounds have a lower frequency. Frequency is measured in hertz. For example, if we perceive a 1,000 hertz sound, it means that 1,000 wavefronts reach our ears in 1 second. The higher the wave speed and the smaller the wavelength, the higher the frequency of a wave. The human ear can detect sound waves with frequencies between 20 Hz and 20,000 Hz. Very deep sounds with a frequency lower than 20 Hz are called infrasound. Very high sounds with a frequency higher than 20,000 Hz are called ultrasound. Bats and dolphins use ultrasound for navigation. The intensity of a sound perceived by the human ear does not depend on the frequency. The intensity of sound is determined by the amplitude of the vibration that reaches the air. In other words, it is determined by the maximum displacement of the vibrating particles in the medium. For non-mechanical waves, the amplitude cannot be interpreted as maximum displacement, so it refers to the maximum value of another parameter. For electromagnetic waves, the amplitude can be interpreted as maximum field strength or maximum voltage. If the wavefronts form a straight line or a plane, the amplitude of the vibration will not decrease during propagation. In general, however, wavefronts are spherical, so the energy carried by the wave spreads over a larger area in space, and its amplitude decreases as it moves away from the source of the disturbance. Since vibration is a cyclic process, the current position of a particle within a cycle can be characterized by a 0 to 360-degree angle. The displacement of a particle from the equilibrium position depends on its current phase. Particles that are in phase move in the same direction at all times, so the phase difference between them is 0. If the phase difference between the vibrating particles is 180 degrees, the particles always move in opposite directions. They are in antiphase. If the phase difference is 90 degrees, the particles are in phase